So the whole point, well, let me just go ahead and get into this in real quick. I do upload these notes. I am uploading them to Canvas. So you'll see where it says lectures. Just select on there.
So all of you do that?
Yeah. And I'll do it. I'm doing it. You'll see the lab notes in there too. And so. Okay. So. Last time we put a mass on a spring. We had some X initial and some X final. And we were looking for the spring constant. So that we could predict, or so that we can predict its frequency. So this is going to have some mass. So basically we have F is equal to a negative kx, all right? And this mass is weighted because gravity is acting in which direction? Down, very good. And so we have another force acting on this spring mass system, and it is mass times gravity, okay? And it should be negative as well. And so we end up with the following. We can say that the net force, according to Newton's second law, the net force equals to mass times acceleration. In this particular case, when we put that mass on that spring, was it moving? You guys remember?
So when you put it like down, yeah, it comes down.
Yeah, I mean, did it move like once we after we put the mass on the spring?
Yeah.
No, it didn't. It stayed still. Didn't it?
I mean, it depends on which weight you have.
We didn't have it going up and down.
Oh no.
It just was still. It was at one. I mean, we didn't have a mass on it. The spring was still, and then we put a mass on it, and the spring. Okay. So we have our net force here. The net force, since it wasn't moving, that means that the acceleration was what? What is the acceleration? If velocity is 0. So 0. And the net forces are going to be the force from the spring plus the force gravity on the mass. So we can put both of those in. Force on the spring plus the force of gravity on the mass equals to 0. That's how we're looking at our net force. If this force wasn't balanced here, you're going to produce some acceleration. If you're in engineering, you're always trying to get this balance. When it comes to like mechanical engineering or mechatronics, you don't want to design a computer and then it falls over. You want to balance that. I mean, because they bumped the table. Y'all follow what I'm saying? You want the chair. When I sit in the chair, you want to know that you're balanced. My weight is being pulled down. The chair is pushing me back up. I'm in equilibrium. You know that? You guys are in physics. You should be happy. This is physics. You should be excited. Oh my goodness. All right. So the spring force is a negative kx, and then we have our mass, our gravitational force, it's m times g.